Hello everyone, myself Vinay Kumaram. I'm pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I gave some brief introduction about the 5th chapter of 9th standard mathematics, that was on introduction to Euclid's geometry. So in this particular video, we'll look into the axioms and postulates which were stated by Euclid. Euclid divided this geometry into two different types. One he named as axioms and the other one he named as postulates. Here, in both axioms and postulates, Euclid does assumptions. So assumptions are done by Euclid in both axioms and postulates. But postulates were more related to geometry. Postulates were more related to geometry and axioms were more related to non-geometric terms also. So in that, if you look into the first axiom, so there are so many axioms in your textbook. There are only 7 axioms given. In the first axiom, he tells that things which are equal to same thing are equal to one another. That means here, if you take two things, one is A and other is B, if these two things are equal to one same thing. So for example, C is the other thing. So now A is equal to C and B is also equal to C, then A will be equal to B. So that means if A is equal to C and B is equal to C, then A is equal to B. So this is one assumption which you should take from this particular first axiom. And in the second axiom, if equals are added to equals, then wholes are equals. For example, now you have phi is equal to phi. So in LHS also you have phi, in RHS also you have phi. So that means basically here phi is equal to phi. For this particular phi which is there in LHS and for the phi which is there in RHS, you will add one equal term. That is, let's say you're adding 2. So that means the same 2 you're adding for this phi and the same 2 you're adding for this phi as well. So when you do that, then this becomes phi plus 2 is equal to phi plus 2. So what is phi plus 2? Phi plus 2 is 7. What is this phi plus 2? This phi plus 2 is also 7. So that means equals which are added by equal. So that means for both the equals you are adding the same term, that is 2. So here phi and phi are equal to each other and you are adding 2 for the both phi's. So that means you are adding equal. So that means you are adding this particular equals. So that means you are taking two different 2's and this 2 you are adding to this phi. I'll write in new slide. So here one phi is there which is equal to other phi and there are two different equals. So one 2 is there, another 2 is there. So two different equals are there. So here for these equals, if you are adding the equals, so that means this 2 you are adding to phi and this 2 also you are adding to this particular phi. So here two equals or equals are added to equals. So here 2 and 2 are equal to each other. Here phi and phi are equal to each other. So these two equals are added to another two equals. So that will become phi plus 2 is equal to phi plus 2. Then the whole terms again will be equal to each other. That is 7 is equal to 7. So that is what this particular axiom 2 states. Now if you look into axiom 3, here if equals are subtracted from equals, remainder. So that means the remaining term will be equal. So that means here again you can take the same example. Phi is equal to phi. You have one equals and again you can take one more equals, that is 2 is equal to 2. So now this 2 you can subtract to phi and this 2 you can subtract to phi. So that means equals are subtracted from equals. So when you do that, phi minus 2 is equal to phi minus 2, you get 3 is equal to 3. So the remaining terms are also equal. So that's why here when equals are subtracted from equals, the remainder are equals. Now looking into the fourth axiom, here things which coincide with one another are equal to one another. For example, if you have two different circles which has same size shape, which has same size and shape, which has same diameter, then these two circles will coincide with each other. So when these two circles have same size and shape, then these two circles coincide with each other. So if these two circles are coinciding with each other, means these two circles are equal to each other. So that means any two shapes which are exactly coinciding with each other, then those two shapes or those two terms are equal to each other. Axioms are used for non-geometry as well. So that means now if A is completely coinciding with B, then A should be equal to B. So that is what this particular fourth axiom is stating. Now if you look into the fifth axiom, in fifth axiom you have the whole is greater than the part. So there are so many parts which come together, or I'll take the example of square. So there are so many squares like this which come together to form a bigger square. So here you can see this is a bigger square. So this is a bigger square which is made of 9 different smaller squares. So all these smaller squares you can consider as part, and this entire bigger square you can consider as whole. So this whole is made out of this particular part. So different parts are arranged together to form a whole structure. So that means here whole is always greater than part, because part is smaller in size. So different parts come together to form a whole structure. So obviously whole will be greater than the part. So coming into the sixth axiom, here things which are double of the same things are equal to one another. So that means in order to understand this, you can take one big line and you can take two lines which are half of this particular big line. So that means here these two lines combine to form this particular bigger line. So that means here I am taking 7 centimeter long line and I am taking 3.5 centimeter and 3.5 centimeter, two different lines. So these two lines, when they join together, it forms this particular big line which is equal to 7 centimeter. So now here exactly double of these two lines. So that means exactly double of one of this particular line will give you this particular bigger line. So that means two such lines, if you are considering, in order to form that bigger line, then these two lines will be equal to each other. So that means here 3.5 centimeter is equal to 3.5 centimeter. So that means double. So for example, if you have a particular shape or a particular thing which is A, and you have two different things which is B and C. So here A is the double of B, that is A is equal to 2B, and at the same time A is also equal to twice the C, that is A is equal to 2C. So if A is equal to 2B and if A is equal to 2C, then B should be equal to C. Similarly, now in the seventh axiom, if A is equal to half of the B and if the same A is also equal to half of the C, then also B will be equal to C. Because A is also equal to half of the B, A is also equal to half of the C. So that's why B and C are equal. So that's why seventh axiom states things which are halves of the same things are equal to each other. So here A is half of B, A is also half of C. So A is half of two different things. So these two different things must be equal, that is B and C. So B is equal to C because A is half of B and A is also half of C. So then this is only possible when B is equal to C. And in sixth axiom, A is twice the B, A is twice the C. This can happen only when B is equal to C. So now we will look into the postulates. We'll look into the first postulate in this particular chapter. So in this first postulate, Euclid assumed that a straight line may be drawn from any one point to another point. So that means a straight line can be drawn from any one point to another point. So for example, if I draw one point, if I put one point here and if I put one point here, a straight line can be drawn between these two points. Similarly, if I put one point here and the other point here, then a straight line can be drawn between these two points. And if I put a point here and another point here, then a line can be drawn from this point to this point. So that means here any straight line can be drawn from one particular point to another particular point in the space. So this is postulate 1. Here we have axiom 5.1 with respect to this postulate 1. And this axiom 5.1 states that only one unique line is possible between two distinct points. For example, if I have a point here and if I have one more point here, and if I ask you to draw a particular straight line between these 2 points, then the only possible way to draw a straight line from this point to this point is this particular line which I have drawn here. So this is the only way to draw a straight line from one particular point to another particular point. Because if you want to draw a straight line between 2 points, then there exists only one unique line between those 2 points. Because now I can connect these 2 points by this way also. I can connect these 2 points by this way also. I can connect these 2 points like this way also. But all these ways are not straight line. These are all curved lines. These are all curved lines. The only straight line here, the condition is we have to draw straight line between 2 points. So that means the only possible way is this particular straight line which I have drawn here between these 2 points. So that means here if I take 2 different points, there is only one possibility to draw a straight line. Or if I take points like this, here also there will be only one possibility to draw a straight line between these 2 points. If you want to join these 2 points by drawing a straight line, then there will be only one unique straight line exist between those 2 points. So that's why this is the axiom of postulate 1. In postulate 1, we tell that a straight line can be drawn between 2 different points in space. In axiom 5.1, we discussed that if you already have 2 different points, then there exists only one unique straight line between those 2 points. If you want to join those 2 points with a straight line, then there exists only one unique solution. Only one unique straight line exists between those 2 points. No other ways are possible. If you are connecting those 2 points through other ways, then those ways are not straight line. If you want to draw a straight line, then there will be only one straight line between 2 different points. This is axiom 5.1. Now looking into the postulate 2. So now looking into the postulate 2, here if you already have a particular straight line, then this particular straight line can be extended indefinitely on both the ends. So that means from this end also you can extend this line indefinitely, and from this end also you can extend this line indefinitely. So this is postulate 2. So there is no restriction that line should stop in that particular point itself. It can extend further also. On the both ends of this line, it can extend indefinitely. This is postulate 2. Coming to the postulate 3, here Euclid assumes that a circle can be drawn from any center and a circle can be drawn from any radius. For example, if I am taking any center point like this, or if I am taking any point like this, keeping this point as center, you can draw a circle. Keeping this point as center, you can draw a circle. Keeping this point as center, you can draw a circle. Similarly, if I give any straight line, you can take this straight line as the radius of this particular circle and draw a circle. If I give one more radius like this or one more straight line like this, you can consider this straight line as the radius of a circle, and you can even draw a circle around that particular straight line. So that means any straight line you can use as the radius of a circle and draw a circle, and any point you can use that as the center and draw a circle for that particular center point. So that's why a circle can be drawn for any center and any radius. Radius means basically straight line. So now looking into the postulate 4. Now looking into the postulate 4. Here also Euclid assumes that all right angles are equal to one another. So if a particular angle is equal to 90 degree, if a particular angle is equal to 90 degree, then that particular angle is known as right angle. So only when the angle is equal to 90 degree, then that particular angle is known as right angle. And any right angles if you take, all those right angles will have angle equal to 90 degree. So that is one more assumption which Euclid has made in this postulate 4. So in postulate 5, what Euclid assumes is that if you draw an intersecting line for two different straight lines like this, there will be an interior angle created with respect to the first straight line and with respect to the second straight line. The angle with respect to this particular second straight line and the angle with respect to this particular first straight line, the interior angle, if you add these two, let me call this angle as A and let me call this angle as B. Now if you are adding A and B together, and if it is less than 180 degree, if it is less than 180 degree, in the statement you should carefully observe, he is telling less than two right angles. Less than two right angles means one right angle is 90 degree, two right angles means it is 90 degree plus 90 degree, that is 180 degree. So less than two right angles means less than 180 degree. So when you add these two interior angles which has been created by this line which is passing through this first and second straight line, so those two interior angles if you are adding, and if it is less than 180 degree, then these two straight line, this is straight line 1 and this is straight line 2, when it is extended indefinitely, then at some particular point these two lines will meet together. So these two lines will meet together at a particular point if they are extended indefinitely. So now you have learnt about axioms. So system of axioms are known as consistent. So you should remember one thing here. Consistent means system of axioms. And postulates which Euclid has given, using these postulates, various statements were proved. So various different results were proved in geometry using these postulates. So various results were proved in geometry. So various results in geometry were proved using these postulates and statements were formed. So using these postulates, various results in the geometry were proved using these postulates, and one general statement or different statements were developed, and those statements are known as theorems. So in geometry you come across lot of theorems, and these theorems are the statements which are proven results, and these results were proved using this Euclid's postulates. So using this Euclid's postulates, various results in geometry were proved and general statements were formed, and these statements are known as theorem, and the statements of these theorems were proved using these postulates. So in the other manner also you can tell this. So this is all there in this particular video. The examples and exercise questions which are there in this particular chapter, I'll be discussing that in my next videos. So until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.